All right, last section. Okay, so I'm sorry you had 3 lessons at the beginning of the week and now 3 lessons at the end of the week. I'm so sorry about that, but it's just how it goes. Okay, chapter 3 is a long chapter. All right, so the homework is going to be on a worksheet. It's going to be 6 problems. You'll see it attached under the assignment there. We are on L'Hôpital's rule. So it's pronounced El Hôpital. El Hôpital. I believe it's French. Okay. It's a throwback to limits, pretty much. So basically, when you can't plug in a limit because it makes the denominator 0, or you get plus or minus infinity over plus or minus infinity, because we can't do that. It's to infinity and beyond. We don't want that. And we don't want a 0 in the denominator because that makes it undefined. So this occurs when you have a rational function and this is happening. You have to take the derivative of the top and the bottom until you can plug it in. But be careful. Don't confuse this with taking a normal derivative, okay? Because this is applying to limits now, all right? So here we go. Number 1, we're finding the limit as x approaches 4 of x squared minus 16 over x minus 4. I can't plug in a 4 for x right now because 4 minus 4 is 0 and I will have a 0 in the denominator. So I'm going to have to use El Hôpital's rule, the LHOP, and take the derivative of the top and bottom until I can plug in the 4. So let's take the derivative of the top of x squared minus 16. That would just be a 2x. The derivative of x minus 4 would just be a 1. Now I can plug in the 4. Oops. Hold on, let me rewrite this. I messed up. Because it's still limit as x approaches 4 of now 2x over 1. My bad. I should have written that. Bad, Mrs. Garcia. Okay, now I can plug in the 4. And that's when you can lose the limit when you're plugging in a number. And 2 times 4 is 8. So the limit as x approaches 4 of this rational function is 8. So this has to do with taking limits of rational functions. Okay. El Hôpital's rule, it makes things really simple for us. Remember when we had to do this at the beginning of this school year? How long those problems were using the x plus h over, or the f of x plus h minus f of x all over h type thing. Like we can do that, but this is way quicker, isn't it? Don't you agree? Let's try another one. Oh, but I'm not going to use a yellow pen for that. All right, so the limit as x approaches 0 of sine of x over x. Okay, well, I can't plug in a 0 for x because that will be a 0 in the denominator, and that's a big no-no. So I got to use El Hôpital, the LHOP. So I'm going to have the limit as x approaches 0 of, in the numerator, the derivative of sine of x is cosine of x. And in the denominator, the derivative of x is a 1. Okay, now I can plug in the 0 for x, cosine of 0. On the unit circle, that's the point 1, 0, and cosine is the x value, so this is a 1. Well, that was easy, right? Number 3. The limit as t approaches 1 of 5t to the 4th minus 4t squared minus 1 all over 10 minus t minus 9t cubed. If I plug in a 1 right now, that'll be a negative 1, and this will be a negative 9. Negative 1 minus 9 is negative 10. 10 minus 10 is 0. And that's why I cannot plug in a 1 right now. It'll make the denominator 0. I can't do that, so I have to use El Hôpital, the LHOP. So I'll have the limit as t approaches 1 of the derivative of the numerator. Using power rule, that would be 20t to the 3rd minus 8t. Derivative of 1 is 0, so I don't need to put anything else. The derivative of the denominator, derivative of 10 is 0. Derivative of negative t would be a negative 1. And the derivative of negative 9t to the 3rd would be negative 27. 9 times 3 is 27. T squared. Now, if I plug in a 1 for t now, it will not make the denominator 0. So I am good to plug it in. So let's plug it in, plug it in. So we'll have 20 times 1 to the 3rd minus 8 times 1 all over negative 1 minus 27 times 1 squared. Okay? Well, 20 times 1 to the third is just 20. Minus 8. 20 minus 8 is 12. 27 times 1 is still the negative 27. So negative 1 minus 27 is negative 28. Reduce that. And we always throw the negative up top. We can reduce out a 4. 12 divided by 4 will give me with negative 3. Negative 28 divided by 4 is the 7. So negative 3 over 7. And there it is. So we can only use L'Hopital's rule when we are taking the limit of a rational function. Last one, and that's the last example, like it's for real the last one. Okay, so we have the limit as t approaches infinity. So I can't plug in an infinity in the top and the bottom, because if I have an infinity in the top and the bottom, then it goes to infinity and beyond, and we don't want that. Okay, we don't want plus or minus infinity over plus or minus infinity. So I have to use L'Hopital, the L-hop. And let's see, we'll have the limit as t approaches infinity of the derivative of the natural log of 3t. Well, I have a function within a function, so I have to use chain rule. So the derivative of 3t would just be a 3 out front, times the derivative overall. Well, the derivative of natural log is 1 over x. In this case, 1 over the x is the 3t. All over the derivative of t squared using power rule would be 2t. Okay, let's clean this up some more. So I'll have the limit as t approaches infinity of 3 times 1/3 t. Well, these 3's will cancel because this 3 technically is in a numerator and this one's in the denominator, so they're diagonally across from each other. So I will have 1 over t divided by 2t. Well, dividing fractions easy as pie, flip the second and multiply. So that'll be a 1 over 2t times 1 over t. So basically it's a 1 over 2t squared. So 2t times t. And now we can plug in infinity into the denominator. That is allowed. That is okay. And you're probably like, what? I don't remember that. But you will. Or maybe you do. It doesn't matter if we square infinity. It's still infinity and beyond. So whenever we have a big bottom, what do? We sit down on the x. So this is where x equals 0. And that's it. Have a good day.